Hi everyone, welcome to NLP project. So in this NLP project, we are going to make here a sentiment analysis model. We will be designing here a Streamlit application where you will be entering a review and then it will be doing the prediction here, something like this. Wow, this is amazing, or this sucks. So whatever the review you type here, based on that review, it will be doing the final prediction. It's not the rocket science, it's a very easy process. So the moreover, there are the two files which I'm running here. The first one is this notebook where I have explained how you can train your model and then how you can store your model so that you can use your model with the Streamlit application file. So this Streamlit application file is running to make the front end, and this notebook is training our model, and the model is stored here. Let me take you through the model. So in the model, we will get started with the NLP introduction. Thereafter, we will learn the NLP applications. Thereafter, we will be discussing some data cleaning process, and then we will be discussing the word embedding techniques, one of the simplest word embedding techniques like the TF-IDF. Thereafter, we will move to install the necessary packages. And then we will be going through with a very important text preprocessing library preprocess KGP Talkie. Thereafter, we will move to the data loading and the preprocessing. And in the next step, we will move to some data visualization. After visualization, we will be learning about the support vector machine, and we will be knowing that what's the difference between the linear support vector machine and the non-linear support vector machine. And then we will also get to know that the some of the advantages and the disadvantages of the support vector machine. And then finally we will move to the TF-IDF vectorization, where we will be doing the train test split, and then the TF-IDF vectorizer and machine learning algorithm will be contained together in a pipeline, and then the training and the prediction will happen. And then finally we will be visualizing the confusion matrix. Thereafter, the final step is storing our model as the sentiment analysis.pkl. Once model is stored, thereafter we will be making here a new file known as app.py. In that, we will be utilizing the Streamlit application here. And in Streamlit, we will be loading our sentiment analysis model, and then we will be designing our front end using Streamlit components, and then finally we will be doing the prediction here at the front end. So whatever the review you provide here, based on that, it predicts like, wow, this is amazing lesson, thanks for watching, something like this. Now you see it has predicted here positive review. And I say here, please like this video. So it says that the positive review. So now, without wasting time, let's go ahead and get started with the actual coding. Alright, let's go ahead and get started with NLP project 2. In this, we are going to build sentiment classification application with the Streamlit. So as you know that the NLP has been there around 20-30 years, and it has been booming in last few years because of new transformer models and advancement in NLP models. There are many applications in NLP. Here are the applications which you can use with the NLP machine learning algorithms. Like you can use for language translation, you can use smart assistant, document analysis, online searches, predictive text, automatic summarization, social media monitoring, chatbot, sentiment analysis, email filtering, and so much more. As I told you earlier that since last 8 years, there has been a lot of advancement in NLP language, and these are transformer based language models, and these models have been providing a very high accuracy in a natural language processing domain. But for the beginner, getting started with these models could be a little difficult. So what we do here, we start with the basics of the NLP. So here we will be starting with the basics of the NLP, where we will be using a basic programming and basic word embedding technique, and just we need to understand that how natural language processing works, and then we will be building a Streamlit application to host our model there. We will be also doing some data cleaning process with our data, like case normalization, removing stop words, removing punctuations and special symbols, lemmatization, stemmings. TF-IDF will be used for the word embedding technique. So TF-IDF is one of the simplest word embedding technique. Before TF-IDF, it is actually be built on bag of words. Thereafter, term frequency and inverse document frequency comes into the picture. But the fundamental, the basic of TF-IDF is bag of words. So the bag of words, you can understand this like if you have 3 documents like I'm high, yes I'm high, I'm kidding, obviously I'm not high. Well, so if you get a token for all these 3 sentences here, and you get a unique token, so you will see there I am high as kidding. These are unique tokens. Thereafter you get here the frequency of these individual tokens in each of these documents. So we see here that doc 1 have 1 frequency for I am high, another one have 1 frequency for each of these 4, and then doc 3 have frequency of 1 and 1 and 1. And if we count these together, you will be seeing their frequency. There is 3 frequency for I, that is the count actually, word count, and for am it is 3, for high it is 2, 1 for s and 1 for kidding. So how this TF-IDF works here, like the TF-IDF is term frequency and inverse document frequency. These two gets multiplied. So what's the term frequency? So the term frequency is like, if I need to know that what is the frequency of I in a document 1. So how many tokens are there in the document 1? So if you sum this, you will get the token document. So 1 plus 1 plus 1, which is 3. So there are 3 tokens in document 1, and I has occurred only once. So it will be divided by 3. So 1 divided by 3, this divided by 3, this divided by 3. So the frequency of each of these tokens in document 1 is 0.33. Similarly, the frequency of these tokens in document 2 is again 0.33 and 0.3 for this one. In doc 3, 0.33, 0.33 and 0.33. And sorry, this is not 0.33. Because 1 plus 1 plus 1 plus 1 is 4. So 1 divided by 4, it becomes 0.25. So here it is 0.25. So the frequency for each of these tokens in document 2 is 0.25. How we calculate the inverse document frequency? It is very much simple. For inverse document frequency, we take a log with base e 1 plus total number of document. So if the number of document is only 3, then we say there, then we take that n is 3, so 1 plus 1 plus 3, which is 4. So this number is always now for a set of corpus, this will be exactly same. So here it is 4. 1 plus 3, that is 4, divided by 1 plus the frequency of that token in that particular document. Like if I need to know that what is the frequency of this in this document, which is 1. So it is 1 plus 3, that's the 4, 1 plus 1, that is the 2 plus 1. So it's the log 2 base e plus 1. That is how you calculate the inverse document frequency. Now you multiply this term frequency and document frequency together, then you get their term frequency and inverse document frequency together, which is known as TF-IDF. Alright, let's go ahead and install all the necessary packages. So we will be installing here a Spacy and a Spacy small language model. Thereafter we will be also installing here beautiful soup 4 and then text blob, ML extend and a pre-process KGP Talkie library. Now let me take you through the pre-process KGP Talkie pre-processing library. This is text pre-processing library. It is hosted at the GitHub. Now at the GitHub, what you will see here, there are dependencies. So these dependencies we need to install to use this pre-process KGP Talkie package. So what it does, it is made to pre-process the text data. It has a lot of the functions, like it can remove the emails, it can extract the emails, it can remove the URLs, or it can extract the URLs. It can remove the HTML tags, retweets, accent characters, special characters. It can remove the stop words. It can extract the stop words. It can get this basic features like the count of words, characters, digits, uppercase. So many features this pre-process package have. If you are planning to build your career in natural language processing, so this is the must-have library for you. So what you can do here, you can come and you can go inside this pre-process KGP Talkie, and thereafter you can click on here in init.py file. So in this you can see all these functions or the method which you can use with this pre-process KGP Talkie. This is very simple. You can just install by using here these link what is given here, or the link is given inside this repo itself here in this readme. So you can install this with this repo readme. Alright, so it has here like get word count, character count, average word length, stop word counts, it has hashtag, it has mentions count, digit count, uppercase count, and contraction to expansion. It has emails, extraction of emails, removal of emails, URLs, removal of URLs, retweet, HTML tag, and so many features are there. So all these features you can use by using this pre-process KGP Talkie. It's very simple. You just need to install the pre-process KGP Talkie and then import pre-process KGP Talkie, and then you can get started with pre-processing package. And these packages are as prerequisite for to use this pre-process KGP Talkie. Spacy is natural language processing tool here. It provides a lot of features like lemmatization and parts of speech tagging and the model building. Thereafter you have a beautiful soup 4, so it provides you to remove the HTML tags. Text blob provide you to find out the sentiments, and then ML extend provides you here so that this provides a feature to plot your confusion matrix in a very natural way, where you can see it in very beautiful heat map. Alright, so you just need to run these. It will install all the necessary packages on your PC. I have already installed all these, so I'm not gonna install again this. So I just believe that you just run all these, it will install. Once you have installed all these necessary packages, then you can get started with importing these here. So I import pandas as PD, and then I import numpy as np, and then I import here matplotlib.pyplot as plt. Thereafter I import here pre-process package, so pre-process KGP Talkie as ps. So here I have all the necessary packages here. Now let's go ahead and read our dataset. So our dataset is hosted here. You need to visit this repo. All CSV ML data files download. In this repo we have our all the CSV files uploaded. Now you just need to read the desired file. And for this tutorial we need here IMDb movie data. So I just uploaded this data, actually IMDb dataset, and this data you need to click on here, and thereafter you need to click on raw. Now it will give you here a raw format link. Otherwise you can right click here and you can copy the link here. So once you copy the link from there, then you are ready to load the model here. So you write here data frame df equal to the pd.read underscore csv, and here you provide the link. Thereafter you just run it. Now it will download this data for you and it will be stored in data frame. Alright, now you check your data here. So in the data frame it is stored. You have two columns, review and sentiment. Let's go ahead and check the shape of this. It is quite huge data, so it has total 50,000 rows and there are two columns. You just need to print these columns for your reference. You have review and sentiment. Let's go ahead and check the head of this data. So df.head, the first 5 rows are printed here. Alright, now the task is to do the pre-processing. So what I'm going to do here, I'm just gonna write here pre-processing. As I have been telling earlier that we are gonna use KGP Talkie preprocess package for the pre-processing. So we'll be using here get word count, character count, get average word length and get stop words count. So these are the 4 methods which we are going to use here. So that those method you can check it here. We are going to use here get word count, get character count, get average word length and get stop word count. So these 4 methods we are going to use, so that you can apply on a review, and here you say that apply, and then we are gonna use here lambda function. Thereafter I write here ps. The ps I have imported pre-process package as a ps, so I write here a ps get word counts. Let me see, where is that? Get word counts, here it is. And if I pass here x, that's when it will iterate over the rows of review. Each of row will be passed here inside ps.get word counts, and then it will be returning here the word for each of these review. Then I'm gonna store these as a variable which is word underscore counts. Now similarly I'm gonna use for other 3 as well. So this whole thing I'm gonna copy and paste it here, and then this one I'm gonna rename as character count, and here I'm gonna say that get car counts. Alright, that's the character count. Then again I'm gonna paste it here. Now I want here the average word length. So here I write ps.get avg word length. Now this I'm gonna just copy and paste it here, a new variable that is the average word length. Thereafter I'm gonna just copy and paste this new line once more, and then here I say get stop word count. So this function will be returning the stop words count. Then I'm just gonna copy this whole thing from here and then paste it here. So these are the 4 property which we are going to calculate using pre-process KGP Talkie package. Thereafter I'm gonna remove HTML tags, because if you see here df.head, so these are HTML tag. So these tags we need to remove. Other than that, we need to normalize this review data. We need to make sure that these gets converted as lowercase data. So for that purpose, what I need to do here, I write here df review equal to df and then review dot apply and then the lambda function, and in this I write here ps dot remove HTML tags, and then I'll pass here x. Other than that, I also need to convert our review as a lowercase, so that you can do with df review equal to df review dot str dot lower. So this will get converted as str, thereafter it will be converted as lowercase. Let's go ahead and run this. So this whole thing gets calculated within a second. Thereafter we are ready to remove the stop words, and then we will be storing that the pre-processed review into the another variable, and that variable we will rename as df review underscore without stop words. So as a part of our data normalization and the pre-processing technique, I'm also gonna remove stop words from the review, and then I'll be testing my algorithm accuracy with stop words and without stop words. So I write here remove stop words. Now you have df review dot apply lambda x ps dot remove stop words x. Let's go ahead and run this. Now if you visualize your data frame df dot head, you should be able to see it here, whatever additional the columns we have added. Like we added word count, character count, average word length, stop words, and thereafter we added here review without stop words. Now you check here, one of the other reviewers has mentioned, alright, and here you check one of the other is removed because those are stop words, and then here reviews mentioned watching one watch, episode you, etc. So what do you see here? That stop words are removed. Now you might ask that what words are stop word? So you can search it here, Spacy stop words. Alright, so Spacy provides here the list of the stop words. Alright, so here Spacy provides a list of the stop words. Let me just see that if it provides here. Okay, seems like that stop words are not here. Let me find out here. Okay. So, okay, that stop word is not present here. Let me just quickly get that. Alright, so I just got the list of the stop words. So I'm just gonna copy and then paste that here. Alright. So I put here stop words. This is quite large list. So this whole list is here, like call, upon, still, nevertheless, down, every, 40, all these things what you see, these are stop words. So these stop words are removed here in review without stop words automatically by using KGP Talkie pre-process package. Alright, so once you have done all these, now we are ready to visualize our data. So what we do here, we will be visualizing these features like word count, character count, average word length, stop word counts for positive sentiment and negative sentiment, just to see that if there is any variation. So what I do here, I import cborn. So I write here import cborn as SNS, and then matplotlib I have already imported, so for that it is not necessary to import. Now we have 4 features. So those 4 features are average word count, character count, stop word count, and the average length. So we need to plot those. Now there are 4 plots, so I'll be plotting those into a 2x2 plot. So for that I set here size of a figure. So I write here fig size equal to, and then here I have 16 cross 8. That's the figure size which I'm gonna use, and then I'm gonna use here the first subplot. Alright, so for first subplot I can write simply plt dot subplot 2x2 plot, and I'm talking about the first plot, and then I write here SNS dot bar plot, and then I say here in X column I want to put my sentiment. So you see there the columns, let me visualize those columns once again here, df dot columns. So we have review and sentiment. There are two types of sentiment, positive and negative. So I put here X equal to sentiment, so it will automatically get the positive and negative sentiment. And similarly I put here Y equal to word count. So the first one I'm gonna get here word counts, and then I pass here data as data frame, which is df. Then I put here the plt dot title. The title is word counts. All right, let's plot this. So as we plot this, what we see here that word counts is plotted. The positive and negative reviews word count, average word count or whatever you see, seems like it is same here. But this bar plot is not showing it correctly. So what we need to do here, we need to plot here a histogram plot. So I'm just gonna delete this, or you can just comment this one. Let's go ahead and plot the histogram just to see it correctly. So I write here SNS dot hist plot, that's the histogram plot. Thereafter you write here the data equal to df, and then you pass here X is equal to word counts, and then on Y I pass again because in histogram there is no Y, so I need to pass a histogram. I need to actually divide the histogram based on the sentiment. So here I need to pass a hue. So hue will change the color of sentiment, color of the word counts based on the sentiment. So I write here hue equal to sentiment, and then I say here the KDE plot equal to true. That's all I need to do, and then just plot this. So as I plot it, what do you see? You see a positive and negative sentiment. There are two colors for positive and negative, and seems like these are getting plotted exactly the same as for positive and negative review. So it doesn't seems there a much difference, but for negative word count seems like a little bit more than the positive one. So there is only a slight change between the positive and negative histogram. All right, thereafter I just copy this whole thing from here and then paste it here. I use here the second subplot. I remove that one. Now instead of the word count, now I want here character counts. All right, now I plot this. So what do I see here? I see for character count here. So the same pattern I can see with the character count as well. In the word count, one more thing you would see here, mostly the words are concentrated around 100 to 200 words. And similarly in case of the character, it is mostly concentrated around 300 to 600 characters here. Alright, and for negative reviews, characters are a little larger than the positive characters. Let's go ahead, copy this and paste it here. Let's plot the third plot. So for the third plot, I want to change this as average word length. And thereafter, I just copy this whole thing again, and I'm going to plot here the fourth plot. And in the fourth plot, I say here stop words count. Stop words counts, that's the name here, you check it, stop words counts. And other than that, here it will be the character count. This will be average, average word length. Thereafter here you have as stop words count. Let's plot this. Finally, you can write here the plt.show to remove this text data. Alright, so what I see again here, that for negative review, average word length seems like a little smaller than the average word length for the positive reviews. That means there are the lesser characters used while describing the word, but the overall number of words are more, but probably the shorthand notation is used while describing. There is some overlap that you can remove with plt.tightplot. So I write here the plt.tightlayout. So with this, whatever the overlapping you had seen, those will get removed. Well, so now you can visualize your features using Seaboard. That is how you can visualize this. Now we have reached at the stage where we can start building our model and we can start doing the word embedding for our data. So for the sentiment classification, we will be using here TF-IDF word embedding techniques and support vector machine. So we'll be using support vector machine learning algorithm. Support vector machine algorithm works something like this, where you will be seeing a multiple hyperspace or hyperplanes. So these, for your example, let's say if you are doing a classification for two classes or binary classes like sentiment classification, and if we try to visualize our data in two-dimensional space, then the samples of one particular sentiment is something like this, and the sample of another sentiment something like this. Then what the support vector machine does here, it first try to draw a line here which can touch the last support vector. So this thing known as support vector, there is a line which is drawn a tangent to this one. Then again there is another line which is again plotted as the tangent of this line, so which is the farthest one, or you can say that whatever the closest one to the central line. So the central line will be drawn here. Then this line is known as maximum margin hyperspace or hyperplane. So along with this line, you will be seeing here each of these classes will be having the maximum, the maximum distance if you calculate the distance between these points and this line. You cannot draw this line to here. If you draw this line, middle line here, you will see there the space between these two lines will be lesser, although the space between these two lines will be larger. So the best fit is drawing these lines in between these two distribution. So this is the example of linear support vector machine, where a linear hyperplane or hyperspace is drawn there. But there are the cases where you will be seeing a non-linear support vector machine. So for non-linear support vector machine, you will see here something like this. So in non-linear support vector machine, these hyperplane can be drawn as a non-linear hyperplane or hyperspace. So these things you can utilize with the sklearn SVM library or the package, so that you can visit from here. So the link for that is given. So you can import from sklearn.svm as SVC. By default, the kernel is used as linear, but anyway you can use the polynomial kernel or RBF kernel. So RBF kernel is non-linear kernel, and polynomial kernel is also non-linear kernel here. In fact, these are also non-linear kernel. Other than that, the support vector machine takes here few parameters which you can pass as C, which is regularization parameter. Other than that, if you pass here any kernel other than the linear, then you can pass the degree of non-linearity as well. So this gamma is also coefficient for RBF kernel, which you can pass. In fact, this is coefficient for RBF polynomial and sigmoid kernel. Then you have here the coefficient, shrinking probability, whether you want to shrink the coefficients or the weights of support vector machines, and whether you want to return the probability from the model or not. So if you enable the probability, so it will get trained 2 times. So ultimately, in fact, it will get trained 5 times. That means it will take a lot of time to train your model. So while enabling the probability, you need to be in a special attention, or you need to be, a special attentive to use this probability, because it will take a lot of time to train your model. If you have imbalanced classes, then you can use here class weight. And similarly, if you want to see the output verbose, then you can use it as a true. So while model will be getting trained, so those will be printed, those logs will be printed there. And this says that how many iteration you want to use for solving the problem. By default, it is -1. That means it will keep solving until it converges to a solution. Alright, so that's the description of support vector machine. This is supervised machine learning algorithm. This can be used for regression and classification both. In this algorithm, as I described you, we plot here, these lines, and then we plot a middle line, which is which actually divides these two distribution into half. There are some advantages and disadvantages of using support vector machine. Like, disadvantages are support vector machine. The advantages of support vector machines are it works really well, and if there is large separation between the classes. If classes are kind of the overlapping, then there is problem with support vector machine. And support vector machine is highly efficient with high dimensional space, and this support vector machine is effective in the case where the number of dimension is greater than the number of samples. That means, let's say if you have only 10,000 samples, but the dimensions which you have built, that's mean the feature dimension is more than 10,000, then in that case support vector machine works really well, and it takes less memory if your data is small. So disadvantage is there. If data is large, then it takes a lot of space. The reason is, for larger data, it trains the model into a multiple hyperspace. So while building those hyperspace, it needs a lot of space there. So it's not memory efficient if you have a large data sample. Other than that, it performs well if your data is clean. It doesn't perform well if there is noise in the data. So these things you need to take care while using support vector machine in your application. Now let's go ahead and get started with the coding. So first of all, we will be importing here train test split from the sklearn.model selection. So moreover, the steps which we are going to now follow, although this step I have already written once, but now we are going to follow the train test split. Thereafter, we will do here TF-IDF vectorization. Thereafter, we will write here ML algorithm. Thereafter, we will do here the fit, and then we will do here prediction, and after the prediction, we need to do evaluation. So this is the step which we are going to follow. Let's go ahead and follow each of these steps one by one. So first we need to import necessary packages. So I import from sklearn.model selection, import train test split. Thereafter from sklearn.featureextraction.text, import TF-IDF vectorizer. Now let me take you through the TF-IDF vectorizer once. That you need to come here inside the sklearn. I'm gonna open a duplicate tab, and then I'm gonna paste it here. Just search it here. So you will see a TF-IDF vectorizer here. You just click this TF-IDF vectorizer. Thereafter you can click on here. Thereafter you will get sklearn.feature extraction.text TF-IDF vectorizer. Let me copy this link and paste that link here for your reference. So I'm just gonna paste it here so that later on you can visit this TF-IDF vectorizer for your reference. Well, so in TF-IDF vectorizer, the process I have already explained. Moreover, it takes here the input. Thereafter, it takes some more parameters, like if you want to strip the accent characters, if you want to make it the lowercase. So that means when we use the TF-IDF, it automatically makes our data by default as the lowercase strings. Thereafter, there is no preprocessor used, tokenizer is none, analyzer is word here. That means each tokens are considered as word. I mean to say that the tokens are broken with the word. That means if you pass this particular data, and in this data, these individual word will be treated as a single token. Thereafter, there is a stop words token patterns. The token pattern, that means during the tokenization how these words will be tokenized. The n-gram 1 that means a single words are taken as a single token. And there is the max df1, min df1. So these things we can set as the parameter. Now you see there the max feature is none. That means it will take as many feature present in your data. So there is no capping in feature selection. Thereafter, you can also pass here vocabulary if you have any vocab from outside. If you want to pass any vocab from outside, you can pass those vocab here as well. Well, so the moreover, you can see these explanation of each of these parameters here. We saw their max df and the min df. So when building the vocabulary, ignore terms that have a document frequency strictly higher than the given threshold. So if frequency of word is more than 1.0, then that will be ignored there. Or at the frequency in a particular word or in a particular sentence. All right. And minimum df says that what it says, when building the vocabulary, ignore terms that have a document frequency strictly lower than the given threshold. So the threshold is 1. When the document frequency is less than 1, then that will be also ignored. So the moreover, what these two parameters are setting here, when a token frequency is exactly 1 by default, only then it consider for the TF-IDF, otherwise it ignored those tokens. Thereafter, these max features said that how many features will be stored in the vocabulary. This n-gram range I have already explained anyway. Alright, so these are the features which we will be using during our TF-IDF vectorization technique. Perfect. Now let's go ahead and import our support vector machine. So I'm gonna import from sklearn.svm import linear svc, that is the linear support vector machine. Thereafter, I'm gonna import pipeline. So from sklearn.pipeline import pipeline. So the pipeline is kind of the container. In that we will be putting TF-IDF vectorizer and support vector machines together. Thereafter, I write here from sklearn.metrics import classification report and then confusion matrix. So if you read this step, so in this step we imported train test split, TF-IDF, ML algorithm, then the pipeline, and this on this ML algo I'll be doing fit and the prediction. Thereafter there would be evaluation, in which we will be getting the classification report and confusion matrix. Let's go ahead and get the train test split data. So I write here x train, x test, y train, and then y test is equal to train test split. You put the parentheses, press shift and double tap just to see the detailed documentation about this function. In this function it says that we need to pass here our data, and if you read it a little bit more, just scroll it down a little, you will be seeing other parameters like the test size. So by default here we will be using 0.2 as a test size. That means 20% of data will be used for the testing. Thereafter the random state, we can set any random state whatever we want. We want to do also shuffle. If it is true, that means data will be shuffled before doing split. Stratify will make sure that our data is splitted in such a way that the target variable is divided as per the ratio defined here in the test size. And it can be written something like this, where we see this train test split returns these 4 variables: xtrain, xtest, ytrain, ytest. It takes these variables as the input parameter, xy, where this is input feature, this is the target variable, and then the test size, random states, and stratify. So these things we can set in our data frame. df review is our review data. Thereafter df sentiment. Thereafter this df sentiment, this one is our target variable. After this we can find out our the test size. Thereafter the random state and stratify. All these we can set. Anyway, so here I set the test size, and then in the test size I set here test size is equal to 0.2, and then the random state I set here 0. Thereafter stratify, I set here the df sentiment. So what it will do here, it will break down the target variable sentiment, and it will split the sentiment as per this test size ratio. Once all these things are done, let's go ahead and run that, and thereafter you can check the shape of xtrain, and thereafter similarly you can check the shape of xtest.shape. So we are having here a 40,000 rows in the train data and 10,000 rows in the test data. Perfect. Thereafter I create here the pipeline CLF is equal to pipeline, and in this pipeline I set here TF-IDF. So here I set TF-IDF vectorizer, and thereafter I set here CLF, that's the classification, and in this I set here linear SVC. So what is happening here, we have a pipeline, term frequency vectorizer, and linear SVC. So this pipeline is working like a container, and in this container we are passing first TF-IDF vectorizer and then linear SVC. In this TF-IDF vectorizer, we are passing all the parameter as it is. We are not going to change anything as of now in this TF-IDF vectorizer. So everything we are gonna keep as it is. And in linear SVC, if you see here, if you put your mouse cursor inside the parentheses, press shift and the double tap, you will be seeing all these parameters for support vector machine as well. But in the support vector machine, we are going to leave all these parameters as it is. That is the default parameter. Once all these things are done, then I just run that. Then I set here the CLF dot fit, and in that I pass here x underscore train and then y underscore train. So in this case I run it, and it will take a while to complete this training, and once the training is done, then we will be doing the prediction. Now you can see the training is done. You have your CLF here which have these steps, which we can see it here itself. It has the TF-IDF and linear SVC. So if a classifier have TF-IDF vectorizer in its pipeline, then you do not need to do the vectorization outside the CLF. That means we can directly pass these text data. So if you see this xtrain, so this xtrain is directly a text data. So we can simply pass this this text data to our classifier, it will automatically do the TF-IDF vectorizer, and then it will do the linear SVC classification. Alright, once all these things are done, then I can simply do like ypred equal to clf dot predict, and in that I pass here x test. Now we have y test, which y test is our true value, that's the base value, and I can compare ypred with the true value, and I can print classification report. So I do here true value, that is the y test, and thereafter ypred, that's the predicted value. So it says that I have got around 90% of accuracy over the sentiment classification, which is good. It's not the bad one, because anyway we have used a simplest model of the TF-IDF vectorizer, and getting 90% of accuracy with just TF-IDF vectorizer and support vector machine is considered a very good accuracy. Let's go ahead and plot the confusion matrix just to see that where it is going wrong. If you remember, in the starting we installed MLExtend library, and now it is the time to use that MLExtend library. So I import MLExtend dot plotting, import plot confusion matrix. Thereafter I calculate the confusion matrix CM equal to confusion matrix. This we imported from sklearn library. I pass here y test, that's the true value, and then I pass here ypred, that's the predicted value. Then I plot here confusion matrix, and there I pass my confusion matrix, which is a CM. Thereafter I just simply plot this, and I see here I see the true label and the predicted label, but I also want to pass here the class names. So for that I pass here class name clf dot classes. It will automatically provide the classes of sentiments. So it has the positive and negative. So a true label of the negative and the predicted label of the negative, but the true label is here a negative, and there is the prediction as the positive. So there are 537 labels are there where the true label were negative, but they got predicted as positive. And similarly, there are 465 labels which are truly positive, but the prediction was a negative. So these are the mismatch. That is why our accuracy was coming around 90% only. Let's go ahead and do the testing and test our model. So I write here the clf dot predict, and then you can do that. Wow, this is amazing lesson. And with this it says that this is positive review. And if I see it here, wow, this sucks, then it says that this is negative review. Let's go ahead and do some more testing, like the clf dot predict, and then I say here please like this video, it helps me a lot. And then see, it says that it is a positive sentiment. Now you have successfully built a sentiment classifier. Let's go ahead and store our model so that we can build here a Streamlit application, so that we can make a front end where we will be putting these review, and then it will be showing us the output as the sentiment, positive or negative sentiment. So here I say import pickle. Thereafter I say here pickle dot dump, and then I pass here classifier clf, and then I pass here file path where I want to store my classifier. So I want to store it into a model name as sentiment underscore analysis, and then dot pkl. I need to open this file into right binary mode, and then I just run it, Now you should be able to see you have your sentiment analysis.pkl, where you will see it was just stored a seconds ago. So we have successfully saved our model. Now it is time to make a Streamlit application. So this application we will be making in a Python file. Let's go ahead and open the directory where our model is stored. So our model is stored here, sentiment analysis, where you see now I need to open this directory into a VS Code Studio. So in a VS Code Studio, I need to now create here a Python file. And if you're not aware with the Visual Code Studio, you can watch this video to install the Visual Code Studio. I'm just gonna put that here. VS Code lesson. You can watch it here. All right, just see it here. And you can click on this link. It will open here a YouTube video where you will be seeing the Visual Code Studio installation for Python programming. Alright, so once you see this Visual Code Studio installation process, then you would be able to work with the code. So I need to create here a new file, app.py. So this app.py will be used here. Alright, so this app.py will be used here to create the Streamlit application. I have already made a video on, actually a video on the NLP project tutorial 1, and there I have shown how you can install Streamlit with on your computer. So there you can open here videos, and here this lecture is available here.
Hi everyone.
And in this I have told how you can install Streamlit application. Well, so once Streamlit is installed in your PC or as a Python package, then you can get started with the coding of your application. So moreover, the process to install the Streamlit is pip install Streamlit. Thereafter you can run the Streamlit with Streamlit run app.py. So this Streamlit you need to define there. The run says that you need to run the application app.py. Perfect. Thereafter you need to import the Streamlit. So you write here import Streamlit as st. Thereafter you write here import pickle. All right, so these two libraries we have imported here. After this library import, now you would see here that I have our pickle model, sentiment analysis.pkl model. We need to load our model. So you write here load model equal to pickle.load, and then we need to pass the file path from where we want to load. So the model name is here sentiment analysis.pkl. Thereafter you need to define in which mode you want to load. I want to load it into read binary mode. Once all these things are done, then you can simply create here the title of your application. So create title. I write here st.title, and in that I write here sentiment analysis model. Let's go ahead and run this Streamlit application. So I just simply copy this from here, and then I press Ctrl and J. So with Ctrl and J you will be getting the terminal. Otherwise you can see the terminal somewhere here. In my case it is hidden here. So you can just simply open a new terminal here. Otherwise you can write here Control Shift and apostrophe. So it will open here a new terminal. Alright, so in this terminal I'm just gonna paste here Streamlit run app.py. Make sure that you are into the same directory where this file is stored. So this file is stored in NLP project 2 and we are inside NLP project 2, and then we run Streamlit run app.py. It's going to run this application. It will be giving us here some port and address where it is being hosted. So I'm just gonna copy this from here, and thereafter I'm gonna paste that here. So I just paste it here. You will be seeing our application sentiment analysis model. Alright, so we have reached till now, till this stage. Now what we need to do here, we need to complete this model. So to complete this model, I need to I need to read the review. So to read the review, I need to provide here a text box in which I'll be writing a review. Thereafter, I'll be providing here a button on which if I click, then it will calculate the sentiment and then it will show a result here. So basically 3 more components we need to add along this panel. The one is input text data, thereafter a button, and thereafter output module here. Let's go ahead and do those quickly. So I write here review equal to st.textInput. So st.textInput will read the text data from the front end. Here I say that enter your review. And if you come back again here, you will be seeing there is option to always run and rerun. So I just click on always rerun. So it will make sure that our application is being run every time. Once we make the changes, it will automatically reflect here if we click on always run on the changes. So now I have got here input text box. Now I need to add here a button. So I add a submit button here, st.button, and in that I write here predict. Now if you see it here, you will be seeing a button is added here. If I click here, add anything here, I won't be seeing any output because this application is not designed for that as of now. So let's complete this designing. Now I write here if submit, that means if submit is clicked, then it's going to do the prediction on the review. So the review is taking input from the text input module or the component. So I write here prediction equal to the model dot predict, and this model is already loaded here, and this model was trained and stored from our Jupyter notebook. So I write here model dot predict, and in this I provide here a list of the review. So since it is just a single review, I provide here with the list there. Thereafter I write here just a print of the prediction, and let's go ahead and see the target here. What I see, if I click on here and then I come back, there I see just a negative review. Obviously that review doesn't make any sense. I have just written there how are you. Let's go ahead and print that at the front end as well. So I write here st.write. So st.write will make sure that whatever you write inside the st.write, those will get printed at the front end. So I write here st.write, and then I write here prediction. I store it, and then I come back again here, and then I just click on predict. It says that the value is negative. Now let's go ahead and test it with our some sample data like wow, this is amazing. And if I predict, it says that it is a positive review. Now the output we are seeing here, the same output we see here, and we see here it is a list. Now if we want to predict it, if we want to decorate our front end, then how it is gonna work? So for front end decoration, we can do the comparison of the predictions value. So what I do here, I write here if prediction. So prediction 0 will make sure that the first value is taken out here, equal to positive. Thereafter I print here a success message with st.success where I say as positive review, and if the prediction is not positive, then obviously it is negative. Then I show here a warning message that negative review. All right, now I'm just gonna hide this from here, because anyway now we are printing it as a success and warning message. Now I come back here, I click on predict. Now it says that positive review with the success dialog here. So there is a green color, that means the success. Congratulations, you have successfully trained TF-IDF sentiment analysis. And we have also built here a Streamlit application which you can use to visualize the front end here. In the sentiment analysis, now you can provide a negative review as well here, like wow, this sucks, something like this, and you do the prediction here. Now you will be seeing here a negative review. Alright, so congratulations, you have successfully built a Streamlit application and a sentiment classification tool. If you have liked this video, please subscribe this channel and share this video on the social media and with your friends. Thank you so much for watching this. I'll see you in next one.